Hey everyone, so if you've ever had to work with complex data like JSON, you know the feeling, right? That pain of a slow query. It can feel like you have to pick one. Either you get rich, flexible data or you get fast performance, but you can't have both. Well, today, we're going to talk about a really powerful tool that lets you have your cake and eat it too. It's called the Gen Index. Let's crack open the secret to making those queries absolutely fly. All right, let's start with a problem that I'm sure is familiar to a lot of you. You've got all this great, flexible JSON data sitting in your database. It's awesome. But then, the moment you need to search inside that data, everything just grinds to a halt. So, why? Why does that happen?
Well, here's the core of the issue, visually. A simple lookup, finding a user by their ID, that's what databases were born to do. It's lightning fast. But a containment query, where you're asking the database to peek inside a complex object and find something, that's a completely different beast. And that's exactly where performance has always hit a massive wall.
The root of this whole problem really comes down to how standard database indexes work. I mean, they're fantastic, but they were designed for simple, sortable values. Think a single number or a piece of text. They just aren't built to understand the rich, nested structures we see in all this modern data.
Here's a good analogy. Think of a standard index like an old-school phone book sorted only by last name. It's great if you know the name you're looking for, but what if you wanted to find everyone who lives on Maple Street? Well, that index is totally useless, right? You'd literally have to read the entire book, page by page. In database land, we call that a full table scan, and it is exactly what your database is forced to do when it tries to search inside JSON without the right tool for the job.
So how do we fix this? How do we solve this problem? Well, the solution is an idea you're already super familiar with, even if you don't know the technical name for it. It's the index you find at the back of any textbook. And there it is. That's the aha moment. Instead of reading the whole book cover to cover, you just flip to the back, you look up your terms, say photosynthesis, and boom, it tells you go look at pages 42, 118, and 256. It maps the content back to its location. And this simple idea is the core principle behind how we're going to supercharge our complex queries. So that back of the book idea, it has a formal name. It's called an inverted index. And it's called that because it literally inverts the typical relationship. Instead of mapping a location to what's inside it, it maps the content itself, the individual words, the numbers, the values, back to all the locations where they appear.
Okay, so that's the theory. How does this concept actually apply in the real world? Well, in a database like CockroachDB, this whole idea is implemented using what's called a Generalized Inverted Index, or GIN index for short. So let's pop the hood and see how it works.
Okay, here's the official definition. A GEN index is built specifically for these container columns, columns that hold other data inside them, like JSON. It creates these crucial maps from the values inside the container directly back to the row they belong to. And that's what makes those find me all rows that contain this value searches so incredibly fast.
So here's how it plays out with the JSON object. When you create a GIN index, the database goes in and it breaks that JSON object down into all of its individual pieces, or tokens. Every single key value pair becomes its own little entry in the index, and each one points back to the original row. So, when you search for, say, location equals NYC, the database doesn't scan the whole table anymore. It just looks up that specific token in the index and instantly gets a list of every row that contains it. It's that simple.
And this is not just for JSON. This is why it's a generalized inverted index. CockroachDB can use this same powerful technique for arrays, for full-text search vectors, and even for strings to do fuzzy searching. But honestly, one of the most exciting applications is with spatial data.
Let's dig into that because it's one of the most powerful applications for this technology, geospatial data. Being able to efficiently query location data is a huge challenge, especially when you're talking about a distributed system.
So the traditional way to do this is to index the objects. You build these really complex data structures like an R tree that kind of draw boundaries around the specific shapes you're trying to store. Now this works, but it can be really difficult to manage and rebalance as your data changes, especially when you're operating at a massive scale.
But CockroachDB, since it was built from the ground up to be distributed, takes a completely different approach. Instead of indexing the objects, it indexes the space itself. It uses Google's S2 geometry library to chop up the entire surface of the Earth into a predictable, predefined grid of cells. And this is an absolute game changer for scaling horizontally, because the index structure is totally independent of the data you actually put into it.
And what that means in practice is that a really complex query like,
find all the coffee shops within the specific neighborhood polygon is no longer some complicated geometric calculation that has to happen at query time. It becomes a simple, blazing fast index lookup to find all the rows that happen to fall within a specific set of those S2 grid cells.
Okay, so we've covered the how, but what does all of this actually mean for your application? Let's talk about the real-world performance payoff. What do you get? Of course, there's no such thing as a free lunch, right? This isn't magic, it's just really smart engineering. And there is a trade-off. What you get is dramatically faster reads, and you unlock all these new use cases that were just impractical before. In exchange, your writes are going to be slightly slower. And that's because the database has to do that extra work of updating the GIN index. But for most read-heavy applications out there, that's a trade-off you will happily make every single time.
So really, the key takeaway is this. GIN indexes give you high-performance queries on the kind of complex data that powers modern applications. They transform what used to be a slow, painful full table scan into a lookup that feels almost instantaneous. It's the difference between searching and actually finding.
And all of this leaves us with one final question to think about. We've gone from indexing simple values to indexing JSON, arrays, and even the planet itself. As our data keeps evolving and getting richer and more complex, what's the next great indexing challenge on the horizon? Something to chew on. Thanks for watching.